Welcome to another lab session. In today's exercise, we will be performing a series of impact tests using the standard Charpy impact test specifications. This test is also known as the Charpy V notch test, and it is a high strain rate test that involves striking a standard notch specimen with a control weight pendulum swung from a set height. This impact test helps to measure the amount of energy that will be absorbed by the specimen during fracture. The equipment that we will be using in this exercise is an Instron Model S1-1K3 Charpy impact tester. It is fitted with a 60-pound hammer on a pendulum, and it has a scale that is used to indicate the energy absorbed by the specimen through the location of a drag indicator after impact. Now let's take a closer look at the impact tester. Now down here is our hammer, and we would raise our hammer to the specified height. The hammer we're using is a 50-pound hammer, and down here is where we would install our specimen for testing. On our scale, you'll notice that we have a drag indicator, which indicates the energy absorbed by the specimen. As you can observe, there are 4 different scales on the dial. We have green, red, yellow, and black. There are 2 factors to determine what scale to use, and that's the height of which the hammer is being raised and also the weight of the hammer. In this experiment, we'll be using the green scale, as our hammer will be fully raised, and we'll be using a 50-pound hammer. While in test mode, to release the hammer, you would pull on this latch, first ensuring that the space is free of any obstructions, as I will demonstrate here. After impact, we would push the lever to the left for brake. Before testing, we would first check for calibration of the pendulum for accuracy by positioning the drag indicator to the maximum value. We would then raise the pendulum to the specified height, and we would release the pendulum without any test specimen in the equipment to allow a free fall. The drag indicator should go to 0, reflecting accuracy since there was no impact. Let's demonstrate. So we're accurate, it went to 0. So to stop the pendulum, we would hit the brake. Now let's have a look at the specimens. The standard size we'll be using for the standard Charpy V notch specimen is 55 millimeters long and a 10 millimeter square, and it has a 2 millimeter depth notch in the center of its length with a tip radius of 0.25 millimeter machined on one face. In some circumstances, sub-sized Charpy specimens can be tested with thickness less than 10 millimeters. The material that we'll be testing in this exercise is 10-18 steel and 66:1 aluminum. We'll be testing these at 5 different temperatures. And for the purpose of this exercise, we will only be illustrating the aluminum. Both our aluminum and steel material will be tested at 5 different temperatures. As you can observe, we have a bath at negative 70 degrees, negative 44 degrees, 0 degrees, 25 degrees, and 100 degrees. Our negative 70 degrees was achieved by a mixture of antifreeze and dry ice. Our negative 44 degrees bath was achieved by a mixture of ice, dry ice, and antifreeze. And our 0 degrees was achieved by pure water and ice. And our room temperature was achieved by just sitting in room temperature water. And our 100 degrees was achieved by sitting in boiling water. Please note that all specimens were placed in their bath for an excess of 45 minutes to assume equilibrium. Let's begin the test. To prepare for testing, we would first raise the hammer to the desired height. Then we would zero our indicator. We would first locate our first specimen at room temperature at 25 degrees. We would then rapidly remove it from the bath, placing it into the testing machine, ensuring that it's in the proper orientation with the notch faced away from the pendulum. Let's test. We would then record that data. But first, for safety, we would break the hammer so it comes to a complete stop. We would then move on to our next specimen by firstly raising the hammer again to the specified height and setting our dial back to the maximum. Then we would move on to our next specimen at 0 degrees Celsius. We would repeat this process until we have completed all specimens at the desired temperatures. So we would do 0, then negative 44, negative 70, and 100 degrees for aluminum specimen. Once we have recorded these values for aluminum specimen, we would then locate our 1081 steel specimen and repeat the process for all 5 specimen at the different temperatures, again at negative 70, negative 44, 0, 25, and 100 degrees. At this point, we would have 2 sets of data, one for the aluminum and another for steel. With that being completed, our exercise would be finished and your data would be transmitted by your professor. Thank you.